Welcome back to another math video in the COVID-19 series. I think this is number 4. Today I'm going to be going over word problems. This is the things I'm going to be talking about today are applicable at any level of math. If a kindergartner is doing math problems and they want to know how to do word problems, you can use these tips all the way up to, I'm a calculus student and I use these when I face word problems. Math is pretty famous for word problems. They can get pretty out of hand. You hear the stories with the math questions where it's like Bob has 1,000 watermelons, and it's like, why does Bob have 1,000 watermelons? That doesn't make any sense. So, math is pretty famous for him. I'm gonna show you how to get through them today. So the basic tips. Number one, most important, is do not panic. Probably the thing that I struggled with the most in this, just because what would happen is I would look at a word problem and there's all this information thrown at you, and that you can get overwhelmed really fast. So the number one goal is not to panic. And I'm just going to leave it at that because that's just a fact. Next, check your answers with logic. I don't want to say that this is a guaranteed thing, just because you might have some weird teacher that is just going to make this weird word problem that's completely illogical. And I know I just made a joke about it right here about how math problems are usually not logical, but generally, for the most part, you're going to be able to check your answers with some logic. And then, as for actually solving them, you're going to ask yourself 3 questions. What is it asking? So, it'll ask you to do something. Every word problem is going to ask you to do something. Solve this, find this, what is this? It's going to ask you to do something. So identify what is it asking. Now, it's also going to give you something. What am I given is the second question you want to ask yourself, because it has to give you some kind of information if it wants you to solve anything. And then your third question is going to be, how can I use what it has given me to find out what it is asking? So how can I use the information it gave me and give it back the information it wants? That's really what it's asking you to do. All you have to do is be able to transform the information it gives you into the information that it wants. That's what a word problem is. So let's get into the first one. So a train travels 1 mile in 1 minute and 30 seconds. At this rate, how far will the train travel in 1 hour? Super, typical question. It's just a train. So, first, what is it asking? How fast is the train going miles per hour? I mean, really, that's what it wants to know. So, what are we given? Well, the train travels 1 mile per 90 seconds. We get that right here. It travels 1 mile in 1 minute and 30 seconds. A minute and 30 seconds is 90 seconds. So, this is what we're given right here. The train is traveling 1 mile every single 90 seconds. So I know that 3,600 seconds equal 1 hour, right? Because my goal is just going to be to convert this 1 mile per 90 seconds into miles per hour. So in order to do that, I need to know how many seconds are in 1 hour. Well, I know that 3,600 seconds are in an hour because 60 seconds times 60 minutes equals 3,600. So all I need to find out is how many 90-second intervals are in 3,600 seconds. And that answer is 40. So this train is going at 40 miles per hour. And so you just convert that into the answer it wants. The train will travel 40 miles in 1 hour. So the last part of this is just check it with logic. Does this make sense, right? Yes, this makes sense. 40 miles an hour, it'll go 40 miles 1 hour. It makes perfect sense. In order to get 40 miles an hour, you divide 3,600 by 90. Let's say you were to mess that up, right? Let's say you divide 90 by 3,600. Well, you're going to get 0.025 miles per hour. A train traveling at 0.025 miles per hour. I know sometimes it feels like that if you're sitting in an intersection, but there's no way a train would be able to do that. If it travels a mile in a minute and a half, it's not going to take it, a year to travel a mile. That doesn't make any sense. So our answer is logical and we win. Next one. A tractor wheel is 88 inches in circumference. That means around the wheel. How many complete turns will the wheel make in rolling a mile on the ground? So what's it asking? How many full rotations of the wheel will happen in 1 mile? Easy. That's what it wants to know. What are we given? Well, we're given that the wheel is 88 inches in circumference, which means there's 88 inches go all the way around the wheel. So basically, how I'm gonna attack this is, okay, well, how many inches are in a mile? Because of the way I look at it, it'll be 88 inches, 88 inches, 88 inches, 88 inches. So if it wants to know how many rotations, I just have to know how many inches are in a mile and then divide it by 88. So I can use this calculation right here. 1 mile is 5,280 feet times 12 inches equals 63,360 inches in a mile. Divide that by the circumference, gets you 720 rotations. Easy. So next one, Bob is flying a kite. The kite is flying at 60 feet, and Bob has let out 156 feet of string. If Bob's kite were to drop onto the ground, how far will Bob be from the crash site? So here I made my little guy. We have Bob right here, and we have his kite up here. So what we are given, well, Bob has let out 156 feet of string, so that's this distance. Now we also know the kite is flying at 60 feet off the ground, so that's this distance. And then it wants to know this. So this is, we have a right triangle right here. This is going to be a Pythagorean theorem, right? We have two sides. We want to know the other one's a right triangle. It meets all the criteria. So we're going to set it up right here. X squared plus 60 squared equals 156 squared. If you are curious about how I'm doing this right now, I have made another video on the Pythagorean theorem. You can go and watch that. So I'm going to roll through it real quick. You're going to get x squared equals 20,736. Take the square root of that. X equals 144 feet. So Bob's crashed kite, poor guy. He's 144 feet from his crashed kite. So last example, this is a monster. So I showed you all the way, just the train one, super straightforward. This is a calculus word problem. This is something that I do in my class. So this is going to be a tough one. So buckle up. Here we go. So a 10-foot ladder is leaning against a wall. The base of the ladder is 6 feet away from the wall. The base of the ladder starts to slide away from the wall at the rate of 3 feet per second. How fast is the ladder sliding down the wall? So here's our triangle, right? This is my ladder. I know it's not a great ladder, but it's a ladder. And the ladder is 10 feet. And then it's 6 feet away from the wall. So this right here is the wall. So it's sliding away at 3 feet per second. We know this. This is just what it gave us. So using a quick Pythagorean theorem, I figured out this is 8 feet right here. So the height is 8 feet. Now it wants to know how fast is this ladder sliding down. It's curious about this number right here. And this is how we're going to get that. So in order to do this, we do get the Pythagorean theorem up, because a squared plus b squared equals c squared, because we're dealing with the right triangle. Now, in order to find rate of change, which is what we're doing right here with the feet per second, you have to take the derivative of this equation. That is something you'll learn to do in calculus. And so this is what you're going to end up in. I know it looks scary, but it's really not. Basically, your a squared turns into 2a times how fast a is changing. Your b squared turns into 2b times how fast b is changing, and your c squared is going to go to 0. And here's why. So a and b are both changing, but c is a 10-foot ladder. C is 10, but the length of the ladder isn't changing as it's sliding down the wall. It's not like if you have a 10-foot ladder and it slides down the wall, it makes it 11 feet, or the ladder shrinks to 8 feet. The ladder stays the same. So the rate of change for the ladder is going to be 0, and 0 times anything is 0. So that's why c squared goes to 0. And then from here, you're just going to plug in what you know. So I know a is 8, right? A, B, C. So a is 8. The rate it's changing is what we're looking for. So it's x. Plus 2 times b is going to be 6, times the rate that b is changing at 3 feet per second. Simplify this. You're going to have 16x plus 36 equals 0. And you're going to get x equals negative 9/4 feet per second. So let's look at this answer. Does this make sense? Is this logical, right? Yeah, it does make sense. If x were to be positive, it would mean that the height of the ladder is increasing. And I don't know any ladder that can slide away from a wall and then also get higher on the wall, right? If a ladder is sliding away from the wall, it's going to be going right down. So this makes sense, because the height is going to have to be decreasing, and this is the rate it's going to be decreasing at. So yeah, that's word problems. Just remember, what is it asking? What am I given? How can I use what I am given to find what it's asking? That's all math word problems are. Don't panic. It's not that bad. And use some logic to check your answer so that you don't, miss easy points. If I were to get a crazy answer here, I'd be like, okay, wait a minute. Let's think about this. Let's go back. And chances are, if you go back and you have a crazy answer, you'll find where you messed up and you'll come out with a logical answer. And that's going to do it. Thank you. This is just another math video. I'll keep on making these to help anybody I can. Again, if you have any specific topic or question you want me to go over, just feel free to leave it in the comments. I hope everybody's safe and sound, and thank you for watching.